that introduction. I'm excited to be here with you all this morning and to continue the sustainability conversation as we are looking at measuring and evaluating Georgia peanut production scenarios using the Fieldprint calculator in the Field to Market Fieldprint platform using their sensitivity analysis. So we've heard many definitions of what it takes to be sustainable. However, of all these definitions that you hear, there are three main pillars that can come in common. And to start, we have the social aspect, which would be meeting the needs of our societies and our consumers, and even our farmers looking from an agricultural standpoint. Economic, so making sure we're getting the greatest return on investment. And also environmental, reducing that environmental footprint is our goal of being sustainable. In the agricultural sustainability realm, we have seen that increased need of agricultural production. And also with that, we've seen that consumer concern with the environment and reducing our environmental footprint. So that has led to that overall consumer demand for sustainably sourced food and fiber products. So that has led us to ask the question, how can we measure peanut growers, their on-farm sustainability as they continue to improve their crop management programs and as they implement new technologies to seek on-farm sustainability improvement? So one way we can do that is by quantifying on-farm sustainability. This gives growers the ability to measure their progress being made. And we can use the Field to Market Fieldprint platform. Field to Market is the Alliance for Sustainable Agriculture. They are an organization made up of different sectors, and land-grant universities are one of those. So the University of Georgia is a part of Field to Market. Field to Market has created a free online calculator called the Field to Market Fieldprint calculator. We can use this calculator to quantify and manage farming practices from year to year. Not only can growers use this, but myself as a researcher can use it as well to manage projects. This Fieldprint calculator measures major commodity crops, such as peanut, cotton, corn, soybeans, and a few more. So the Fieldprint calculator, we enter in our growers' field management information in an online questionnaire. And it provides scores for 8 different sustainability metrics. And you can see on the screen, this is a spidergram graph that you get at the end of the questionnaire. You can see on the screen, we have the land use metric, or that measures yield, soil conservation, soil carbon, irrigation water use, and depending if you have an irrigated or dryland field, you may or may not have this metric. Energy use, greenhouse gas emissions, water quality, and biodiversity. And so we can compare our grower scores, which are in the blue, and compare those to project, state, and national benchmarks. So the objective of our research is to evaluate a sensitivity analysis of peanut production practices using the Field to Market Fieldprint calculator, and to evaluate the way sustainability metrics can be improved and how they vary from year to year. So this study began in 2014 with just one peanut grower. And as of 2021, we have grown to 45 currently enrolled growers that are located across the Southeast and Southwest Extension districts of Georgia. And so as of 2021, we had a total of 236 fields that we had measured sustainability metrics for. And so to collect this data, I meet with our growers individually for about an hour at the location of their discretion. And you can see I helped the grower plant some corn one day while collecting his field management practices. But we collect their previous year's peanut field information. So this year in 2022, I'm collecting the growers' 2021 data. And then I also, in our meeting, present the growers with an annual grower report. And this has been really unique to this project, as we've been able to sit down with the growers and show them the spidergrams like I just showed you. But if the grower has had information for us for the last 2, 3+ years, we can compare those spidergrams and show the trends that their farm is seeing over time. And also, we are running the sensitivity analysis. These sensitivity analysis, or running simulations of sorts, will provide growers with potential crop production scenarios. So for the sensitivity analysis, I created 4 base crop scenarios for cotton peanut rotation in the Fieldprint platform. So this is just a snippet of the Fieldprint platform and what that looked like once I entered in the different production scenarios for those rotations. We then based these 4 crop production scenarios off of the UGA enterprise budgets. These enterprise budgets are a very interesting tool that we can use to help give us a baseline or an average of what a crop producer might endure in a season, whether that's the equipment that they put out in the field, how many times they had sprayer applications, and even an average of irrigation, how many times that would have been applied through the season. So this just gave us a baseline average of what we're going to base our sensitivity analysis off of. So we did those 4 crop production scenarios included an irrigated conventional treatment, irrigated strip till, dryland conventional, and dryland strip till. So in the Fieldprint calculator, we use these 4 base scenarios and applied them to the total 236 fields, which gave us a total of 944 outputs. I do want to mention a study that was done by Porter et al. Starting from 2014 and ending in 2019. This was a peanut irrigation study that looked at 3 different scheduling treatments. There was a dryland treatment using the UGA checkbook irrigation method, as well as the use of soil moisture sensors using the watermark sensors. So for this study, we will eventually run the 4 base scenarios and add the treatment results. So that would be yield and the amount of irrigation that was applied during those years, and apply those to the 236 fields. And that will give us a total of 9,440 outputs or different scenarios. But for the simplicity of today's presentation and for time restraints, I'm just going to go over some of those base results from those 4 base scenarios. And our data were analyzed using R. So getting into the results, I'm only going to go over 3 of the 8 sustainability metrics today just for time, but I believe these 3 sustainability metrics are going to get us in the right direction when it comes to where we can talk with growers and make some improvements. And the first is greenhouse gas emissions. So I'm first going to show you this component table. So we have 2017 to 2020, and then this is in proportion. So you can think of it as a 0 to 100%. And so you can see from this table in the dark green at the top, that is application. Then we have irrigation in the orange. And then if you look at that lime green, that is going to be post-harvest management of peanuts. So we can see from this table that those 3 components that contribute to the greenhouse gas emissions are going to be the greatest contributors. And there's slight variation through year, but for the most part is very consistent from 2017 to 2020. With that being said, we're looking at the different tillage practices, so the conventional versus strip till, and on our y-axis we have the kilograms of CO2 emitted per kilogram of yield. And from this table, we can see that both the dryland strip till and dryland conventional had significantly lower greenhouse gas emissions than both irrigation treatments. So this is not a real surprise to me, as we've seen from that table that showed that irrigation did play a large component to greenhouse gas emissions, that this is a continuum of the story. But I also want to point out that the strip till irrigated treatments did have a slightly lower greenhouse gas emission than those conventional, and that would be due to the production management that goes into strip till production. Next, we're looking at soil conservation, which correlates to soil erosion. Here was kind of surprising that across both the conventional and strip till treatments, as well as the dryland and irrigated treatments, that there was no statistical difference across these. We do see a visual increase in those conventional treatments. However, there was really no variation across those, which I was slightly surprised by. And then lastly, getting into soil carbon. So soil carbon is very important, and it will relate back to soil conservation and soil erosion, as we want to have a goal of keeping as much soil carbon in the soil as possible for soil physical properties, reducing erosion and leaching of nutrients in the soil. So here we have our tillage treatments on our y-axis, and we have the soil carbon index on our x-axis. So if you see that center black line, that is going to be 0, so neither gaining nor losing. If you go to the left of that line, you're going to be losing soil carbon. To the right of that line, gaining soil carbon. So from this table, we can see that our strip till, both dry land and irrigated treatments, were really close to the center, so neither gaining nor losing. We are hoping that maybe after running some future simulations, maybe looking at that Porter et al. Study, maybe those boxes will start to fluctuate a little more. But compared to the conventional treatment, which was definitely losing soil carbon, that was a great improvement. So the use of the field to market Fieldprint calculator can serve as a method to quantifying and measuring peanut sustainability. This sensitivity analysis can help to evaluate how production scenarios impact sustainability metrics over a multi-year span. So we did see that dry land fields did have lower greenhouse gas emissions, but we did see that those irrigated strip till fields were lower than irrigated conventional fields. And lastly, we did see that the strip till fields had greater soil carbon index of those in the conventional treatments. And also, implementation of improved management practices can help to improve on-farm sustainability. So for our future work, we are continuing to meet with growers. Like I stated, I'm meeting with growers this year to collect their 2021 information to enter into the Fieldprint calculator. And our goal is to add 5 growers each year of this ongoing research. So our goal is to hopefully have a nice 75 growers by the end of the study. And then also we are going to continue to evaluate the additional management practices which affect change in the 8 different sustainability metrics. So going back to that Porter et al. Peanut irrigation study, seeing how those will fluctuate when we implement precision ag technologies and some of these new technologies into production scenarios. But also, I think it is going to be very interesting, and we heard Dr. Scott Mumford talk about yesterday, was the reduction of pesticide use. So what is that going to look like from an economic as well as a sustainability standpoint for our producers in the future? So with that, I would like to give a special thanks to Dr. Eric Cornell at the American Peanut Council and Dr. Gina Nichols at Field to Market with their assistance of this research. And I'd also like to thank the American Peanut Council, the Georgia Peanut Commission, as well as Cotton Incorporated for their funding of this research. And with that, I'd love to take any questions.
Thank you, Kate. We have time for questions.
Yes.
Thank you very much. Things that I want to have and before we use. So you mentioned that the dry land and that makes sense. But also the irrigating somewhere where it's not less rainfall like Texas. Must have, I guess, a very different environmental impact than irrigating somewhere like a little bit of that off the rain. Do you have a weighting to take that into account?
So the question was, are we going to take account to the irrigation water use and water quality metrics? Is that correct? Yes, so that is definitely going to be at the top of our priority. So of the 8 sustainability metrics, we did have irrigation water use and the water quality metric, as well as I want to mention energy use. And so those are going to be some other top metrics, especially when we go back to that Porter et al. Study that did have the different irrigation treatments. I think that will be very interesting. And since that was a multi-year project, we had wet years, dry years. So we're going to have some very interesting simulations and scenarios from that study. So yes, we are looking forward to running the data on that project. We will be able to answer that question soon.
My work is how are you identifying and recruiting growers to participate in this? Growers are very busy. They appreciate what you're doing. They want somebody else to do it for them. They would rather not be the grower involved. How do you gain 5 more growers per year, and how do you make sure that the makeup, the diversity within those grower productions fits into what you're looking for?
Sure. So the question was, how do I, as an extension researcher, recruit 5 new growers each year for this project. And I will say, I'll give any shout out to extension agents in the room. They are the gateway to my growers. And so I meet with extension agents. I call them up, ask them if they can identify any growers that would be interested in meeting with me for 1 hour for a year, and going over some sustainability. I think as I've only been in this project for 2 years, and of the 2 years that I've been a part of this research, I believe the narrative of sustainability is changing with the use of the Contras Protocol and now the Sustainable U.S. Peanut Initiative. I believe that the narrative is changing. Growers are starting to seek the importance of measuring their on-farm sustainability. So once I talk with extension agents and they can identify, you know, we've looked at small, medium, large growers, you know, we don't discriminate. And so then we meet with these growers and they seem to be excited about learning about these metrics and almost have a self-competition of trying to improve their metrics from year to year. So it's been very interesting so far.
That's the time we have. Thanks so much.
Thank you.